right? I'm going to have to go up 1 unit because f of x is on the 1, g of x is on the 2. So I'm definitely going to have to go up 1 unit. What else? Once I do that, what else needs to happen?
The function stretches so it gets thinner.
Good. So there's a stretch. And we know that stretching means it gets skinnier or thinner. Skinnier. There we go. Okay, cool. So that's visually what's happening. But now we're going to translate that and use our values for A and K. So remind me, what type of numbers are going to turn the graph skinnier?
Fractions.
Whole numbers.
Whole numbers. So that is a very, very common little mistake that happens. And it happens to me too, because I'm like, oh, skinnier means smaller, smaller fractions, fractions make things skinnier, but that's not true, okay? So fractions make things wider and whole numbers make things skinnier. So try to remember that because it's a little bit counterintuitive. So this tells me that A is going to be greater than 1. A is going to be a number greater than 1. And then if I'm going up 1 unit, which variable controls vertical, up and down?
K.
K. And if I'm going up, that means K is positive 1. So which answer choice matches the best?
A.
A.
Answer choice A. Good. So I did have a few people, actually like half of the people who answered me chose C as their first answer. Why do we think that happened? And
Most of the people got confused because I think they meant fractions had to make this thing skinnier.
Yeah, so it's actually, I was not surprised at all because the same thing happened this morning in my first period. So just make sure we understand the difference. When you got a fraction, it gets wider. When you have a whole number greater than 1, it gets skinnier. So kind of a little review of yesterday's lesson. Do I have questions on this problem? Now, from yesterday's class, we are kind of continuing to talk about what we learned yesterday, but just make sure that if there's anything from yesterday's class that you feel unsure about, or if you were absent, or for whatever reason, I cannot stress this enough. This week, more than ever in your lives, this week is the week where you have to go back and watch those videos if you miss anything, because it's a lot of information. Kind of, it all came at us really fast, like boom, boom, boom. We learned a lot of stuff in like 4 days. I can't teach it again. And your test is after spring break. So now we got spring break to worry about, and a lot of you are going to start forgetting some things over spring break. So like even if you were in class, if you understand everything, you feel great about it, I still want you to go back and review by watching the videos because it is a lot of information. And we got to make sure we remember it after spring break. Okay? So I'm going to watch those views. I'm going to make sure those views go up. I have a couple views on already, but I want to see those views go up. Okay, today we're moving on to something called standard form. So yesterday we talked all about vertex form. Today we're going to look at standard form. So here's my standard form equation, and it's basically just another way to write quadratic functions. You can write them in vertex form, or you could write them in standard form. And before we really get into it, can we just shout out some observations that we notice about this equation?
A constant.
Good, we have a constant. Beautiful. What else? What else do we have?
In vertex form, the X is in the parentheses, but here it's right next to the A.
Yeah, so there's no parentheses. There's 2 different terms with an X in it. And someone's asking me, what is the title of the lesson? The title of the lesson is just standard form. That's what we're learning about today. Okay, so okay, there's a constant, there's no parentheses. Someone's saying the leading coefficient is 1. But I want us to think about that again. The leading coefficient isn't 1. What is the leading coefficient? I see it in the chat. It's A. It's A. Does that ring a bell? Does that ring a bell? Should look pretty similar because in vertex form, there's also A, and it's also the leading coefficient. So we'll talk about that in a moment. Somebody else is telling me, okay, there's an exponent. Yeah, I have an exponent of 2. Is that different than vertex form or the same as vertex form? Think back to vertex form. Does vertex form have an exponent? Look back in your notes. Look back at what vertex form looks like. Does it have an exponent in it? There we go. Yeah, it does. Let me show you an example really quickly. Here's a vertex form equation. Where's the exponent?
Outside the parentheses.
Yeah, it's there. It's outside the parentheses, but it's still there. And that makes sense, right? Because what type of function are we talking about? What's this function? What type of it? Ooh, what are words? What type of function is this?
Quadratic.
Quadratic. And we know that quadratic functions have to have an exponent of 2. All of them. They always do because that's what a quadratic, what does that remind you of? Reminds me of a square, quadratic, square, exponent of 2. So you're going to notice that even though we're in a different form, it's standard form, but you still have a lot of similarities. The leading coefficient is A, the exponent is still 2. And lastly, what type of expression is this? I see 3 terms. What is this called?
Trinomial.
Good, Miriam, trinomial. So, some differences, right? There's no parentheses. There's 2 different x's. So those things are different, but there's also some similarities. We have a leading coefficient of A, so that's the same. And the exponent is still a 2. So what we're going to talk about now is how to read this equation and make it make sense, basically. Because remember, what happened with standard form? Standard form gives us a lot of information. What are some things that a standard form equation tells you about the graph? Or vertex form, I'm sorry. What does vertex form tell us about the graph? What's one thing?
It tells you the translations.
It tells you the translations. What else does vertex form tell us from yesterday's class?
Where the vertex is.
Where the vertex is. So it tells us the H, the K, the A. There's a lot of information. Standard form tells us a few things as well. Oh, Christopher's also saying it tells you how wide it is. That's also true. Standard form tells us some information as well. So let's go ahead and write that down. So each of these letters is going to tell us a different thing. A is the same thing as vertex form. So who can remind me from vertex form, what does A tell us about the graph?
How wide it is.
How wide it is, yeah. So it tells us the width.
And it also tells us whether or not it's flipped or not.
And it tells you whether or not to flip it, yeah. So it tells us the width and the direction it points. So as a reminder, this is the same thing as vertex form. If A is a number greater than 1, what's happening? Is it going to get skinnier or is it going to get wider?
Wider.
Wider. No, not
Or
wider.
skinnier.
Skinnier. Don't make. We keep making that same little mistake. That's okay. So this is a stretch. It gets skinnier. If A is a number between 0 and 1, what does that mean?
It's a compression, so it gets wider.
There we go. That's a compression. So it gets wider. And if A is a negative number less than 0, what happens?
It'll be a reflection.
It'll be a reflection. Okay, so that's all the same exact as vertex form. It's the same exact information. Now, the other thing that I can know from this equation is the c, the constant. This number is my y-intercept. Does vertex form tell us where the y-intercept is located?
No. Yes.
Vertex form?
Oh no, vertex form doesn't.
Vertex form does not. Vertex form tells me the vertex, but it doesn't tell us the y-intercept. Well, standard form tells us the y-intercept, but does it tell us the vertex?
No.
No. So it's kind of a trade-off, right? If you write it one way, you kind of know some things about the function. If you write it a different way, you're going to know other things about the function, but neither one is going to tell us the full story. So,
But Miss, can't you turn standard form into vertex form?
don't get ahead of yourself. Wait for the next slide. Okay, so real quick, I have 3 examples down below, and I just want to go ahead and describe what I know about each of these functions based on the numbers. What are some things I know about each of these? So starting with number 1. I know that A, what's the value of, what's my leading coefficient?
1.
1. C is 9. So what are the 2 things I know about this function?
The vertex is 1, 9.
I don't remember writing that down in my
9,
The
1.
y-intercept is 9.
the y-intercept is 9. I don't know anything about the vertex. I don't know a single thing about the vertex. All I know is that the y-intercept is 9. And what does A tell me?
It'll be a stretch.
Think again.
Well, no, wait. Oh,
Think again.
Right now.
If A is just 1,
it just stays like a normal size.
yeah.
So like a U-shaped.
Yeah, so there is no stretch, there's no compression. I would just say that this is neutral. And which direction does it face? Does it face up or does it face down? So I have a positive 1. Positive 1. So am I facing upwards or downwards?
Upwards.
Upwards, good. Positive numbers face upwards, negative numbers go down. So this is it. That's everything I know. I don't know anything about the vertex. I don't know anything about the y-intercept or the x-intercepts, nothing else. All I know is that the y-intercept is at the 9 and that it's going to be a neutral shape facing upwards. That's it. So let's try the second one. How about for number 2, what do I know?
That your y-intercept is 147.
Good. The y-intercept is 147. Okay, that's pretty big. What else do I know?
The leading coefficient
Is 4. So what does that 4 tell me about the shape of the graph?
It's
It'll
gonna
It's
be
up.
kind of
So it's upwards and
Stretches.
It's gonna be stretched.
stretched. Good. Good. And then lastly, number 3. What do I know here? For number 3, what do I know?
Your constant is 10.
The constant is 10. So that's the y-intercept. And what does A tell me?
The leading coefficient is negative 16.
Mm-hmm. And what is that telling me about the shape of my graph?
It's gonna be flipped,
It's going to be flipped, so it's going to face downwards,
and it's gonna be stretched
and it's going to be stretched. Why is it stretched and not compressed?
because it's a whole number.
The number 16 is think of it separately from the negative sign. The negative sign tells me that it's flipping. The 16 tells me that it's stretching because 16 is a number greater than 1 on its own. Does that make sense? Any questions on these 3? Think about it for a moment. I'll give everyone about 10 more seconds. Think about it. Any questions? Now, again, do I know the vertex at all on any of these?
No.
No. Also, does B tell me anything? Does the B tell me anything?
No.
Nothing at all. So those numbers in the middle, they don't really tell me anything. All right. Okay. Now, let's check this out. So Christopher kind of predicted what's happening next. Remember what I said? Vertex.
Wait, Miss.
Oh, what? You're still writing?
Yeah, give me like 10 more seconds, please.
Okay, 10 more seconds. Go ahead. And by the way, this is a good page to take a quick picture, quick screenshot. This is a good page for studying.
Okay, thank you, Miss.
You're welcome. Anyone else still writing?
No, but I have a question. When is the quiz?
Quiz tomorrow, as usual, on Fridays.
Oh no, I mean test.
Test right after spring break. The Monday after spring break will be our review day, and then you test Tuesday and Wednesday.
Okay.
Okay. So now I have a vertex form equation, but remember what I said, vertex form is one way to write it. Standard form is just a different way to write the same thing. So what we can do is we can actually turn vertex form into standard form. So let's go ahead and let's go through the steps to do that. And those of you who enjoyed what we were doing last week when we were doing foiling and polynomials and adding polynomials and combining like terms, all that, you're going to like this because we're going to do that again. So how to go from vertex form to standard form. Step 1, we're going to FOIL the binomial. Remember, we have an exponent of 2. What does an exponent of 2 tell me to do?
Square.
Square it. What does it mean to square?
Multiply by itself.
Multiply it times itself. So I'm going to rewrite this equation here. And this is telling me to multiply times itself. So I'm going to write it as x minus 1 times x minus 1.
Wait, Miss, wouldn't it be at x plus 1 then?
Nope. I'm just taking what I have and I'm copying and pasting times itself. Okay? So we're going to go ahead and we're going to FOIL. So quick review of FOIL. What do I multiply first?
2 and x.
Okay, that would be distributing. I'm not distributing right now. I'm going to FOIL. So between these two binomials, what goes
X
first?
and X.
X and X, yeah. We'll distribute later, okay? So X times X, what do I get?
X squared.
X squared. What goes next?
Outer.
The outer one. So X times -1, what do I get?
-1x.
-1x. Next, what goes next?
Inner.
Inner, inside. -1 times X,
-1x.
again, -1x. And then finally, what's left?
Last.
The last two. -1 times -1.
1.
+1. Good. So I FOILed my binomial. Now I'm going to bring everything down. Step 2, we're going to combine like terms. Combine like terms. Where are my like terms?
-1x and -1x.
Yeah, right in here. -1 and -1. What does that give me?
-2x.
-2. Good. -2x. So we FOILed, we combined like terms. Now I can go ahead and distribute that too. So here we go. Boom, boom, boom. 3 times. What am I going to get when I distribute?
2x.
2x squared,
-4x
-4x,
and +2.
and +2. Bring down your last number over here, -7. And the last step is just to combine like terms again. Because what do I still need to combine?
+2, -7.
+2 and -7. 2 minus 7, what do I get?
-5.
-5. So we started out with vertex form. Now I have standard form. 2x squared minus 4x minus 5. Standard form. And the thing is, you can always do this. You can start from vertex form and you can turn it into standard form by following those four steps. Now, it might seem like a lot. It kind of is a lot of steps, but at the same time, it's also all things that we know how to do already. We know how to FOIL, we know how to combine like terms, we know how to distribute, and we know how to combine like terms again. So each individual step is just a review of something you've already learned how to do. So take a look, make sure you're writing everything down, and let me know if anyone has any questions. No questions? All right. Cool. Well, now let's talk about why we did what we just did. Like, why would I want to do this? So I started with vertex form. What does vertex form tell me?
The vertex.
The vertex, right? Then I figured out standard form. What does standard form tell me?
The y-intercept.
the y-intercept. So I started off with limited information. I only knew the vertex, which helps me a little bit, but it doesn't give me the full picture. But now I know the vertex and the y-intercept, and that's enough information to graph this function. So next thing we're going to do is we're going to graph. Again, any final questions on this? Okay. So I'm going to erase the steps, and let's see if we can graph it. So if I remember correctly, my graph does not have the right amount of numbers on it. Hold on. Yeah, it doesn't go low enough. So I'm going to make a new graph real quick. Okay. So give me 1 second so I can draw it out. All right. Cool. Okay. So let's take a look at what we know, because now I have vertex form and I have standard form, so I have a lot of information available to me. Going back to vertex form, let's just quickly review. The vertex is located at h, k. So looking at my vertex form equation, which of those is my h? Okay, so -1, but what do I need to do to that number?
+1.
We got to flip it, yeah. So -1 becomes +1. So h is +1, and what is k?
-7.
-7. So my vertex is located at 1, -7. All right, and I take that just from my equation. No math necessary. So I'm going to put down my vertex, 1, -7. 1, 2, 3, 4, 5, 6, 7. There it is. Okay, so I know my vertex. What else do I know now that I have it in standard form as well? I know the y-intercept. What is the y-intercept?
-5.
-5, yeah. So remember this number right here at the end, the constant, that's your y-intercept. It's -5. So I can put that down as well. 1, 2, 3, 4, 5. -5. So now I've got these 2 points. And to connect all the dots, I just need to look at my value of a. What is a?
2.
It's 2. And notice, does a change from my vertex to my standard?
Nope.
No, it's
No.
the same number, same a. A is 2. So what does that tell me about the shape and the direction of my graph?
It stays the same.
It'll be a stretch
It'll be a stretch and it's facing
upward.
Or
upward. So that's the missing piece of the puzzle, because now I know that when I go to my vertex, I'm going to go upward. And whatever happens on the left side of my graph, what happens on the right?
The same thing.
The same thing. So since I know what happens on the left side, I can just reflect it, mirror it on the right side. So now I have my parabola and I'm done. I didn't have to, well, okay. Obviously I had to do math to get to this point, but that's why it's so useful to have vertex form and standard form, because each of those on its own doesn't tell you the whole story. Vertex form tells you the vertex, standard form tells you the y-intercept. Put them together, you can graph the whole parabola, because you can graph the vertex, you can graph the y-intercept, and put it together. So it's very useful to be able to convert it going from one to the other. Questions in the chat. Why is h positive 1?
Because that's the constant.
It's not the constant, so be
Oh,
careful.
miss, my bad. Because you have to flip it.
You have to flip it. I see a negative, I got to flip it and turn it to a positive. We went over that yesterday, so if you're not really sure about that, make sure you go back and watch the video. Whatever h is, you flip the sign. So h is positive 1. That's the only time that happens. -7 is still -7, +2 is still +2, -5 is still -5. So the only time you flip things is for h. Other questions? That's all? Okay, let's do a couple more. We'll get more and more used to it the more we do it. So, example number 2. Same exact situation. I have vertex form. I want to turn it into standard form. So I'm not going to write down the steps. I want you guys to look back on your notes and tell me what to do. What do I do first?
Foil.
Foil, good. So what that means is first I just need to write this. Write this out. We copy and paste. We're multiplying x plus 1 times itself. So I'm just writing it out. And now I can foil. X times x, what do I get?
X squared.
X squared.
X squared. X times 1, what do I get?
Just X.
Just x. I'm going to write 1x because that just helps me to remember that it's a 1. 1 times x,
The same thing.
same thing, 1x. And 1 times 1?
1.
1. Okay, I'm going to bring everything down. Now what?
Combine like terms inside the parentheses.
So, okay, so we want to combine like terms before we distribute, okay? You could distribute at this point. It's not wrong, but it's going to be a little bit more neat if you combine like terms first. So combining like terms, 1 plus 1,
2.
2. All right, so far, any questions? All right, now I can distribute. Distributing my -3, what do I get?
-3x.
Mm-hmm.
-6. X. -6x. -3.
And -3. Bring down -2. And last thing,
Combine like terms.
combine like terms again. -3
-5.
and -2 make -5. There it is. We have our standard form equation, which now we can use to put everything together. So now what we're going to do, same thing. We're going to just write down everything we know about this function. What do we know? What's one thing we know?
The y-intercept is -5.
The y-intercept is -5. Okay, what else do I know?
The h is -1.
The h is -1, good. I see a plus sign. I need to flip that sign. So I know that h is -1. What else?
And A is
leading-
-3.
So A is -3. The
And
leading
it's also the leading coefficient.
Mm-hmm. All right, and there's one more thing I haven't written down yet.
Oh,
So vertex.
K is -2.
Good.
also K
Yeah,
is -2.
K is -2. Okay, so now this is everything I know. And let's organize this information. Based on H and K, what do I know now?
The vertex
Y.
is -1 and comma -2.
Good. -1, comma, -2. What else? Based on A, what do I know?
It's gonna be a reflection?
It's going to be a reflection. It's going to be a stretch.
Perfect. Stretch and reflection, so it faces downward. And now that's everything. That's everything I can possibly learn about this whole graph. So I can put it all together and graph it. So my vertex is at -1, comma, -2. My y-intercept is -5. It faces downward. So when I connect these dots, I go down. And whatever I get on the right side,
You get on the left.
you get on the left. So I just repeat it on the other side.
Miss, can't you just select it and then just copy it and paste it?
No,
And then flip
because
it?
on this app, the one thing I don't like about this app, let me just show you. I know exactly what you want to do. I'm just going to draw a random shape, whatever. If I want to flip it, I can't like flip it. I can turn it around. I can make it bigger and smaller, but I can't like flip it over. So
That is stupid.
yeah, so I can't do that.
Also, I asked you a question in chat.
So we know everything we can about this graph, except we apparently don't know its zodiac sign, according to Chris. I think it's a Virgo.
We also,
It kind of looks like a Virgo to
we,
me.
we also don't know its favorite snack.
No, we don't. Okay, any questions on this one? On a scale of 1 to 10, tell me in the chat how we feel about this whole process. 0 means you don't know anything and you feel totally lost and you hate math and you hate me and you hate school and you hate everything.
What's a 0? Just kidding.
And 10 is like, if I took the test right now, I would get 100%. Okay.
Miss, I don't think it's that bad. It's just a lot of math.
Yeah, that's the issue with this. It's like a lot of places where you can possibly make a mistake, but each individual part of it is not that bad. But when you put it all together, it's just a lot. So my goal is just to keep practicing it as much as you can so that we feel more comfortable with it. Because after a while, the more you do it, the more it just becomes like second nature and you can do it a lot more easily. So with that in mind, let's do another one. All right, I have a fraction, but let's not get too crazy with it. I think it's going to be just fine. Don't get scared. Fractions are okay. What should I do first?
Foil.
We FOIL. So I have x plus 3 times x plus 3. Oops, plus 8. Okay, FOIL. Here we go.
X
I got a
squared.
question.
Sure, what's your question? While I write, what's your question?
So, you know how you always do like put it 2 times?
Mm-hmm.
Like, what if the number is like, is it always gonna be 2?
It's always going to be the same, whatever's in the parentheses times itself. So you just copy and paste it. It's the 2 of the same thing. Because that's what the exponent is telling me to do, right? The exponent is a 2, So it's saying, okay, take it and multiply it times itself.
Oh, so like, can it be like, can that exponent?
Can that exponent be a different number?
Yeah.
If it was a different number, it would no longer be quadratic,
Oh, yeah.
right? Because remember, quadratic functions, the exponent is always a 2. So for our class, the answer to that question is no, it won't be a different number. Eventually, if you take algebra 2, you're going to see what happens when it is a different number. But right now, we're only going to go up to the number 2.
This
Okay.
keyword if.
If, I mean, when you take algebra 2.
Wait, algebra 2 is a high school class?
Yeah. Okay. X squared, then 3 times x, I get 3x. 3 times x again. I get
3x.
Yeah, I get another 3x. And finally, 3 times 3.
9.
9. Good. Bring everything down. Now, what do?
Combine like term.
Combine like terms. 3 plus 3.
6x.
6x. Okay, now the time has come. The moment has come. We got to deal with this fraction. 1/3, negative 1/3 times x.
Negative 1/3 x squared.
Yep. Can't do anything else about it. We just put them together. Negative 1/3 x squared. What about negative 1/3 times 6?
Would it be negative 2x?
It sure would. Negative 2. Negative 2x. Quickly, let me go ahead and go through that because I'm sure someone out there has a question. Make this a little smaller. Okay. What did we just do? We just did 1/3. Come on. Okay, 1/3 times 6. Well, we did negative 1/3 times 6. 1/3
So-
times 6.
So pretty much what you did was you swapped the 1 for the 6.
6 over 1.
Yes, you
Swap-
swapped the
Oh, I
yeah,
see what you
and then-
mean.
yeah.
You get
So
6
instead it
over
would be
3.
6 over 3, and then you simplify it.
6 divided by 3 is 2. And obviously this is all negative. So negative, negative 2. Multiplying by now, we've done this enough times, guys, that if you see fractions, you shouldn't feel quite as terrified as maybe you did in October. Hopefully you're getting a little bit better at those. How about negative 1/3 times 9?
3.
-3.
Good,
Mhm.
negative 3. Same thing. Negative 1/3 times 9 over 1. That's 9 divided by 3, negative. So that's negative 3. Okay, and now I bring down my positive 8, put it all together. What do I get in the end?
Standard form.
I get standard form, but what's that number going to be at the end? Negative 3 plus 8.
Positive 5.
Positive 5. So my standard form is negative 1/3 x squared minus 2x plus 5. So this one was a little bit more challenging because of that fraction, but at the end of the day, we're still following those same steps. Nothing is different. It just means you got to try a little harder to make sure that you get your fractions right. Questions on the math? Okay. Now let's talk about it. What do we know?
The leading
The y
coefficient is
intercept is
negative 1.
The leading coefficient is negative 1/3. So here, now I'm running out of room. Let's see. I'm going to make this a little bit smaller. I hope that's okay. Just so I have room. Okay, and I'll zoom in a little bit. Okay, the leading coefficient is -1/3. What else do I know?
The y-intercept is 5.
The y-intercept is 5. Okay, what else?
H is -3.
H is -3. Perfect.
The k is 8.
K is 8. All right, and now let's talk about what all of these things do to my graph. So shout it out. Based on these numbers, what else do I know?
Vertex is -3, 8.
3, 8.
The vertex, you are like fighting to get it first. The vertex is -3, 8.
So it's flipped and being compressed.
It's flipped. Let me bring this down. How do we know it's flipped?
Negative.
Negative.
Because it's negative, so it faces down. And how do you know it's compressed?
Fraction.
The fraction. So the fraction makes it compress, the negative makes it flip. Those are two separate things going on. So fraction makes it wider, and the negative symbol makes it face down. And the y-intercept is 5, and I think that's everything, right? So let's go ahead. -3, 8. My y-intercept is 5. I'm going down, and it's going to look like really wide. And whatever happens on the right side
Happens on the left.
Comes on the left side.
happens on the left side. So there we have it. There's our beautiful parabola. 1, 2, 3, 4. So kind of estimating, but that point looks like it's going to go right there. Actually, I think it's a little too far. 1, 2, 3. 1, 2, 3. Yeah, I'm one off. Let me redo that. So what I just did, if anyone's wondering, remember that this graph is symmetrical. So there's an axis of symmetry right down the middle. And I just counted how far away from the middle is the y-intercept. It's 3 units away. So on the other side, I also just want to make sure I go 3 units the other direction. Just to make sure it's like perfectly going through the right point. All right, how do we feel now? Give me a number in the chat. Out of 10, do we feel better? Do we feel worse? How do we feel? 0.9 better, that's good. Good, some people are getting a little bit better. Some people are staying the same. So like I said, the more practice, the better it's gonna get. Okay, someone brought up something very, very important that I want to talk about. So someone said they feel good, but they're not so sure about how to shape the graph. Remember that on your actual test, you're not going to have to graph it. What are you going to have to do?
Put it in
Identify.
standard.
You might have to put it into standard form, but if there's a graph, yeah, if there's a graph, it's going to be a multiple choice scenario. So you're not going to graph it, but you have to know everything about the graph. And we know how to do that part, right? We can write all of the information down and then see which of the answer choices matches all that information. Okay, so if you feel a little bit like graphing is going to be hard, don't stress about that part because it's more important to be able to match it to the correct graph. Cool. And again, the next test is not until after spring break. So we do have a little bit of time, but over spring break, you know, we got to make sure we're studying to make sure we remember everything. Okay, so perfect timing, guys. We're doing so well. So we've looked at vertex form going to standard form. Now, actually, I'm going to skip this problem. Now, what happens when all you have is standard form? So they gave me this equation. It's in standard form. What do I know and what do I not know?
You don't know the vertex. The vertex.
Yeah, we don't know the vertex. But what do we know?
The y-intercept.
Yeah, we do know the y-intercept. So in this case, would I be able to graph it?
No.
No. Because, okay, I can put the y-intercept down. It's at -5. Okay, there's -5. But without the vertex, I don't really know where it's going to be. I know that, okay, a equals 1. So it's facing what? Up or down?
Up.
Down.
Up, up. It's facing upward, but it could be anywhere. It could be here. It could be here. It could be here. It could be like this. I have no idea. Without the vertex, I don't know where the graph actually is. So we're going to learn real quick how to figure out the vertex if all you have is standard form. And the way that we're going to do it is using the vertex formula. It's a super simple formula. I know it sounds scary, but it's not. I would like everyone to go ahead and write this down. The vertex formula, h equals -b over 2a. That's it. H equals -b over 2a.
Miss, we wanted to figure out the vertex, not the area of a triangle.
It's not the area of a triangle. Don't make me, oh, you didn't have Miss Weaver. I was about to call her up. This is our vertex formula. And it's very, very useful because I don't know the vertex, but I can figure it out. So we're gonna do that right now. I'm gonna go ahead and make this a little bit smaller. It's not going anywhere. I'll put it right in the corner. Oh my goodness. If I'm able to, there we go. So first off, let's just label everything real quick. We know, we already said a equals 1, c equals -5. And now we're actually going to use the letter b. We haven't really bothered about it before, but now we're going to use it. b is -4. And what we're going to do is we're going to use the numbers and put them into our formula. So h equals -b over 2a. I'm going to plug in my b, which is -4. And I'm going to plug in my a, which is 1.
So Miss, it would be +4 over 1.
It would be
Over 2.
+4 over 2, and 4 divided by 2
2.
is 2. Now, this is my h. So I just found out that h equals 2. That's great, but what am I missing? In order to know the vertex,
Okay.
I also need to know the k. So in order to find k, all you need to do is take the h and plug it in to your original equation. So I have my original equation right here. And I'm just going to be plugging the number that I got for h everywhere that you see an x. So I'm plugging in 2 both of those times.
So you do that to get the k.
So you do that to get the k, exactly. And now it just takes a little bit of math. 2 to the power of 2, what do I get?
4.
4. -4 times 2?
-8.
-8. And then -5. And I would do that real quick. 4 minus 8.
-4.
And -4 minus 5.
1.
1.
-4 minus 1.
Oh, -9.
-9. And just like that, now I have k. K is -9. So now I can put everything together. Now I know everything I need. The vertex is 2, -9. What else do I know from the start?
Y-intercept is -5.
The y-intercept is -5. And where is my graph? What's the shape of my graph?
It's gonna be thin, stretch.
Is it going to be stretched?
It's gonna be neutral,
Isn't
isn't
it
it?
neutral?
Neutral, yeah. Upward or downward?
Upward.
Upward. Okay, so now I can graph. Now that I have all my information, I can graph. Now, my graph does not have the right numbers on it again, so I need to fix that. I should have fixed it before class. I apologize. Give me one moment. Technical difficulties. Okay. There we go. So, because I need to go all the way down to -9. But this is good, because at the same time, you guys can sketch your own graph. It doesn't have to be perfect, but make it look nice. Okay, here we go. Putting everything in, the vertex is at 2, -9. The y-intercept is -5. 1, 2, 3, 4, 5. It's neutral, facing upwards. Here we go. Up we go on one side, and up I go on the other side. Oh, I could do better than that. There we go. So that's where we are. That's what my graph looks like. Vertex formula, super important. That is something that you definitely want to memorize. This little tiny formula gets you a lot of information, because if you don't have vertex form, if all you have is standard form, and you don't know where the vertex is, you can always find it using that formula. So it's going to be super useful. How do we feel about all this? Any questions? Take a look through it, make sure that you're writing things down, and see if anything doesn't make sense. And like I said, we'll do a few more examples. Hopefully I can get 2 more examples by the end of class. All right, let's do another. Here we go. First, we're gonna list everything we know. I wanna know what is A. I wanna know what is B. I wanna know what is C. There's something fishy about this one. What's happening?
There's only 2
Yeah.
terms.
There's only 2 terms, so one of those is missing. Which one's missing? A, B, or C?
The A.
A.
B,
Miss, how you gonna throw us to the wolves? It's immediately as we start learning how to walk.
So go back to this problem real quick. A is always the term that has the exponent of 2. Okay? So the leading coefficient is always wherever the exponent is, that's the leading coefficient. So I'll ask again, which one is missing?
A. O.
B.
B.
B is missing. So I have a leading coefficient. So I know A is -16. There's no B, so what is the value of B?
0.
Yeah.
0
And C
is
is
10.
From here, we go ahead and we use our super handy dandy formula. H equals what?
-B
Oh.
over 2A.
Good. So negative B over 2A, what's B?
B is 0.
B is 0.
So it'll be -0.
Yeah. And -16 is A. Okay, so I have -0, which is just 0. 2 times negative 16 is negative 32. But what's 0 divided by anything?
0.
0. Now, I included this question because a lot of times students they get 0 and they freak out. Like, that can't be real. Like, that can't happen. That's not true. But
Actually,
it
can happen.
It actually can. It's totally okay. 0 is still a number. Just because you got 0 doesn't mean the world is ending. We're still going to keep going the same exact way. Because
Miss,
what should I
wouldn't
do
it-
next?
Well, you have to find
The vertex formula?
Yes. Yes.
I mean the vertex, yeah, the vertex form.
So I used the vertex formula already, but now that I have the value of h, what do I do with it?
The value of k.
We have to find the value of k. And how do I do that?
You plug it into the original equation.
Plug it into the original equation, exactly. So every time after you've done the formula, you got h, just plug it back in so that you can figure out the value of k. So I'm finding h of 0.
And then you just combine like terms.
Well, when I plug in 0, what do I get?
It's
Zero.
1.
0. 0 to the power of 2. 0 times 0
0.
is
0.
0. And 0 times negative 16,
It's still 0.
it's still 0. So this whole thing gives me 0. 0 plus 10
It's 10.
is 10. So the k is 10. Well, hold up. Where else do we see a 10?
Oh, it's also the
Y-intercept?
y-intercept.
It's the y-intercept.
Therefore, it starts off at the y-intercept.
The vertex is the y-intercept. Exactly. So 0, comma 10 is here. The vertex and the y-intercept are the same point. And that happens sometimes. That's totally okay. It doesn't happen all the time, but every so often, it just happens that they match up at the same exact spot. So, am I facing upwards or downwards? Where do I-
Upwards. No, downward.
Downwards. Good. And stretch or compression?
Stretch.
Stretch.
Big stretch, right? 16, that's going to make it super, super skinny. So there's not much else I can do, but I do know it's going to look something like this. And it's just a sketch. It's not a perfect graph because I don't have any other points, unfortunately. Since the y-intercept and the vertex are at the same location, I can't use the y-intercept to shape my graph. So I just have to kind of guess what it's going to look like. But I know that it's facing downwards. I know it's going to be really skinny. So this is a pretty good idea of what it will look like in the end. All right, how do we feel now? Any questions? We'll do one more. All right, so last one. Let's do this one. So what I want you guys to do on this one is figure out the H, figure out the K on your own. So I'm going to leave this blank as it is, and I want you guys to take about 2 minutes, figure out the H, and then figure out the K. And when you get your answers, send them to me in the chat. Okay, I'm gonna add 30 more seconds because I know a couple people are still working. All right, last few seconds, and that's time. All right, let's go through it together. What is A? Shout it out.
6,
6. What is B?
24,
24. What is C?
14.
Good job, you know your ABCs. I'm sorry, I make really bad jokes. It's a lot more fun when we're all in person.
Miss, what about D, E, F, and so on?
Oh, I'm sorry, you don't know your ABCs then. It's too bad. Okay, H equals negative B over 2A. So, negative B, what am I plugging in? What do I get?
24.
Negative 24.
So I get negative 24, and then 2 times 6
12.
is 12. So what's negative 24 divided by 12?
-2.
Negative 2.
Negative 2. We got H. What do I do with that number now?
You plug it in.
Plug it
The
right
original.
back. Yeah, plug it all in. Do I plug it only one time in one of the x's?
No, twice in both of them.
Twice. Plug it in for both of those x's. All right, y equals 6. Plug it in. Plug it in again. Negative 2. What is negative 2 to the power of 2?
+4.
Positive 4. And what is 4 times 6?
Wait, did you say +6 and -4?
It's positive 4, like you just said. So what's 4
Okay.
times 6?
That's +24.
Positive 24. Good. I'm just skipping a couple steps because I want to go fast. All right. 24 times negative 2.
-48.
And plus 14 at the end. 24 minus 48 plus 14. A little bit of math. Do it in your head if you can. What do we get?
-10.
-38.
Negative 24.
So 24 minus 48, I get negative 24, but now I have to add 14.
38.
Add 14.
Negative. It's gonna be a negative.
Negative.
Negative what?
10.
10. Negative 10. So 24 minus 48 gives me negative 24, but then I have to add 14, so I'm going the other way. So I get negative 10. So my k is negative 10. What else do I know about this graph?
H is negative. Oh, sorry. That's the vertex. -2, -10.
Good. The vertex is negative 2, negative 10. Keep it going. What else do I know?
Y-intercept.
Y-intercept is 14.
The y-intercept is 14. Okay, and then finally,
A tells you that since it's +6, it's gonna be a stretch and it'll be facing upwards.
facing upwards and a stretch. All right, let's do it. Negative 2, negative 10 is going to put me right over here. The y-intercept is 14. That's just underneath the 15, so I'll estimate it. I'm going up, 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 and on the other side, same thing. Oh, that's so ugly. Let me fix that. Let's fix that. Okay, there we go. That's a little bit better. And that's it. That's my graph. I am done. So we're almost out of time, but if you're feeling a little overwhelmed, if you're feeling like there's a lot going on and you just need to practice it, like you just want to just do it a few times to really get it into your head, then you might be interested in my extra credit opportunity. So listen carefully. I am going to post it on Teams later, but I already posted an extra credit Khan Academy. It's going to be due the next Wednesday. So that's March. Let me do this real quick. March 24th. And the assignment is already on Khan Academy. However, in order to earn extra credit, what do you have to do first?
Do all your makeup assignments.
Anything you still need to make up has to be done first. I will not be giving you extra credit if you have any Z's in the gradebook. So only if you're done with everything else, do this assignment, which is just the same as everything we've done in class the last 2 days. So on the assignment, you'll see it'll give you an equation and then you have a graph and you have to move the dots to put the graph where it's supposed to be. Also, since it's extra credit, you will only get an A from it. So if you do it and you get a bad grade, I won't put it in the gradebook. If you do it and you get 100%, I'll put it in the gradebook. Does anyone have questions on that? When's the marking period over?
Next week.
Next week, but my gradebook is closing Wednesday at midnight. That's why this is due on Wednesday at midnight, because I'm going to grade all through Thursday and I have to submit it by Friday. So if you have any makeup work that's still overdue by Wednesday at midnight, this date, the 24th, that's the day that everything is due. Not there. You try to get something in by Thursday, no chance. I'm not going to grade it that day. All right. So this is for Khan Academy and anything on Teams. Khan and Teams. All right. Any last questions on all of that? Okay. So if you still need to bring those grades up, check to see if you have any other missing work, do that work, and make sure you also do the work that's due this week. Friday at midnight, there's one assignment that's due then. So with all that in mind, have a great, lovely afternoon. I will see everybody tomorrow.
Bye, miss. Have a good
Bye,
day.
Miss.
Bye, everybody.
I do have one question.
Chris, what's your question?
Stay up a question.
Okay, you have a
Oh.
question too?
So since you're gonna be grading all day on Thursday, don't you think it'd be a really good idea to take the day off
No, that would be a terrible idea.
so that way you
Sorry.
can grade?
No.
Fine.
All right, what was your question, Dehan?
So pretty much my laptop's been having issues for like the whole year since 7th grade. Can I be able to get a new one at the school?
Can you get a new one? I don't know if they have any. Your best chance is going to be to just go in and ask, because I don't know off the top of my head if they have any.
Okay.
But if they do, they'll give you one. So that's your best chance. Go ask, and hopefully you do have one.
All right.
Okay. And Colt, go on your grade book. Look for any Z's. Look for a Z. If you see a Z, that's a missing assignment. I'm not going to go and do it myself. So you have to do, it's your responsibility. Okay. All right. Okay. Any other questions, guys? That's it. All right. Have a good day, everyone.